Okay, my 8th graders, lesson 6.2, describing functions. So building off of lesson 6.1 and understanding with functions that an input can only have one output because it is following a specific rule. So their essential question on this lesson is, how can you tell if a function is linear or not? Well, I hope your brains are saying, it forms a line, linear, and yes, there's only one circumstance where it's not considered a function though. So in short, I'm going to go ahead and explain that, and then we'll get into the examples that the book takes us through too. But in short, how would I know if a function is linear or not? So if I had a function that looked like this, then that's a line. Now so the linear part is good, check, but I need to make sure that each of my inputs have their own output. And so here are my inputs along here, and then here's the outputs along here, and there's nothing vertical, right? There's no input that has two different outputs, and it's a straight line. So if it's a straight line and none of the inputs have more than one output, then I'm in good shape. So this would be a linear function. This would be a linear function. Well, pretend that's a straight line. But yeah, this would be a linear function because each of my inputs have a different output. And it's a straight line. So linear is a straight line. Function, each of my inputs have a different output. The only time you're not going to get a linear function when you have a straight line is if my straight line looks like that, because this input, so yes, in fact, it is a straight line. So yes, one of the requirements is met, but here is an input with this output and 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 this output, all of these outputs from the same input. So I'm not applying a rule to this input that is one specific rule and then coming out with all kinds of different outputs for that one input. So the only time it's not a linear function is when the line let me rephrase that. The only time you don't have a linear function when you have a line showing is if the line is vertical. Okay, so with that in short summary sort of thing for this lesson, let's go ahead and take a look at the explore activity that they gave for us. This poor guy. Have you ever had your umbrella do that? I have had my umbrella do that. He's just getting poured on. The U.S. Department of Agriculture defines heavy rain as rain that falls at a rate of 1.5 centimeters per hour, or 1.5 centimeters per every 1 hour. So they have this here. You guys are getting super good at putting things in y equals mx plus b format. I have a rate, so I have an output is going to be 1.5 times every hour, and there's no rain before that, so I can put it plus 0 or leave it off. This is the scenario I'm looking at. That's why you see the input 0, output 0, because there's no y-intercept. Output, oops, that's an eraser. Output is y, and so for every hour, 1 hour is 1.5 inches of rain. So we could fill this in using the calculation. 2 hours is going to be 3 inches of rain. 3 hours will be, you got it, 4.5 inches of rain. 4 hours would be double this, right? 6 inches of rain. And 5 inches would be 6 plus an inch and a half, 7.5 inches of rain. So they want us to plot these ordered pairs from the table on the coordinate plane here. So these are my x, these are my y. X to go this far on the x, turn, go this far on the y, go this far on the x, turn, go this far on the y. So I'm going to go ahead and plot those. 0 on the x, turn, 0 on the y, that's easy. 1 on the x, 1.5 on the y, right about here. 2 on the x, turn, go 3 on the y, right about here. 3 on the x, turn, and go 4.5 on the y. 3 on the x, turn, go 4.5 on the y, right about there. 4 on the x, turn and go 6 on the y, 4 on the x, 6 on the y, right about here. And then finally 5 on the x and 7.5 on the y. 5 on the x, turn and go 7.5 on the y is going to put me right about there. And here you'll see, here I have a straight line. And the straight line is really representing every possible answer. Every dot represents an answer for this input. That's the output. This input, that's the output, all the in-betweens. So if they ask me how much rain falls in 3.5 hours and 3.5 hours, I could come up here and see where it crosses. And if that's hard to see on my line, I'll just calculate it then. 1.5 times 3.5. Run that through my calculator. And it just seemed faster for me to calculate it than open up my calculator. I'm going to get 5.25 as my answer. So how much rain falls in 5 hours? 5.25 inches. I had two ways I could solve that. I could go to 3.5, find where it goes across on there. Since it was hard to tell, I used the equation instead. It goes 1.5 every hour. So I did 1.5 times 3.5 hours. And that told me 5.25. What do you notice about all the points you plotted? They were in a straight line. Is the total amount of rain that falls a function of the number of hours that rain has been falling? Why or why not? It is falling at a rate of 1.5 per every hour. So it is a rule that is happening to it during that constant heavy rain period. So yes, it would be considered a function because we're not getting different answers, each of our inputs has its own output. Or better said is, yes, each input has one output, not its own output, but one output. It doesn't have many outputs. So that's what this part is helping us to understand. All right, let's look at another possible function. We have a temperature at dawn that was 8 degrees Fahrenheit and increased steadily, positive, 2 degrees every hour. So 2 degrees in 1 hour, another 2 in another hour, another 2 in another hour. So repeated addition would be multiplication. The equation y equals 2x, 2 per hour, plus 8, the starting point, gives the temperature y after x hours. State whether the relationship between the time and the temperature is proportional or non-proportional, and then graph the function. Okay, remembering proportional and non-proportional, we know if it's proportional or non-proportional. If we have to be proportional, two things have to happen. The two things are, it needs to be in a straight line, and that straight line needs to go through origin, 0, 0, this point right there. Now, hopefully, and maybe you don't notice it, and that's okay, hopefully you're starting to recognize that if I have y equals 2x plus 8, that plus 8 is my y-intercept. That means I'm going through y-intercept, or the y-axis, at 8, not at 0. In order for it to go through origin, that would have to be 0. So maybe just y equals 2x and done. Y equals 2x plus 0 would make that through origin. So as soon as I have a y-intercept that's not 0, then I'm not going through origin. So I could stop reading right at this question, and if I'm really comfortable with what all of these stand for, that could have been enough. You could have said, no, it's not proportional because it's going through 8 at the y-axis, not through 0. So if you're feeling really comfortable with that, that could have been it. We can compare this equation with the general linear equation y equals mx plus b, where m equals 2 and b equals 8m is the slope m, b is the y-intercept. Therefore, the equation is a linear equation. So we know it's linear. We know it makes a line because it goes in that format. But b does not equal 0, and it would need to equal 0. The relationship is non-proportional. So the linear part was fine. The origin part was not. Okay? To graph this, I would take that 2x plus 8 from the equation, choose some x coordinates, 0, 2, 4, 6. I would use 0, 1, 2, 3. But whatever they want to use there, I guess. 2 times 0 plus 8 equals 8. When x is 0, y is 8. Plug in the 2 for the x here. 2 times 2 is 4 plus 8, 12. When x is 2, y is 12. When x is 4 and you plug it in, you get 16. For input 4, output 16. When x is the input of 6, you put it through the equation. 2 times 6 is 12 plus 8 is 20. We graph the ordered pairs, 0 on the x, 8 on the y. 2 on the x, turn and go 12 on the y, boom. 4 on the x, turn and go 16 on the y, boom. 6 on the x, turn and go 20 on the y, boom. Draw the line. It is a straight line, but not going through origin. My inputs have only one output, so also this is a function. All right, we have a square tile. It has a side length of x inches. We don't know how many inches, but it's square, so it's to find the area of it, we would do length times height, or length times width, and since they're the same, it would be the same length times the same width, or x times x, which is x to the second power, because we're finding the square, that times that. It gives the area of the tile in square inches. Determine whether the relationship between x and y is linear, and if so, if it is proportional. Well, let's go linear first. We have this equation, y equals x squared, y equals, that's the formula that we're going to run it through, x to the second power. Let's choose some x possibilities, 1, 2, 3, 4, that's more like it. Let's use easy ones, right? So if I plug in 1 for x, 1 to the second power is 1, so when x is 1, y is 1. When x is 2, 2 to the second power, that is 2 times itself twice, so 2 times 2 is 4. When x is 2, y is 4. If my input is 3, that is 3 to the second power, that's 3 times itself twice, so 3 times 3 is 9. When x is 3, y is 9. And when x is 4, 4 to the second power is 16. When x is 4, y is 16, each input having one output, so that's something to keep in mind. Although that's not a question they're asking us here. Just something I'm trying to make sure your brain is digesting. Now that I have some coordinates, let's graph it. Go 1 on the x, turn, and go 1 on the y. Boom, boom, right there. 2 on the x, turn, and go 4 on the y. 2 on the x, 4 on the y. 3 on the x, turn, and go 9 on the y. 3 on the x, 9 on the y. 4 on the x, turn, go 16 on the y. 4 on the x, 16 on the y. Connect the dotty dotties. Do, 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 do. That is not a straight line. So I don't meet that criteria. It looks like it would go through origin, because if x was 0, 0 to the second power is 0 still. 0 times 0 is still 0. So yes, it goes through origin, but it is not a straight line. So my answer is non-proportional, because it is not a straight line. It doesn't have the same rate of change over time. It's changing differently. If I went -1 times, if this were to continue at -1 times to the second power, this whole thing is going to happen, because you're going to go a -1 input is a +1 output, and then a -2 input is a +4 output. These things, you'll get more into this later in math, these things are called parabolas. Don't they look so happy? They're parabolas. Anytime you have to the second power going on in your equation up here, you're going to get some form of a parabola this way, or maybe it's a sad parabola, or maybe it's a, I don't know, sideways parabola. But anytime, just a heads up, you get that x to the second power, you're going to get a parabola. My last question to you, though, on this would be function, maybe not a linear function, but do each of my inputs have their own output? Yes, yes they do. Not their own. I need to fix that. I shouldn't say their own. Do each of my inputs have exactly one output? Yes, yes they do. They don't have more than one output. I don't see another 2 over here with a different output than 4. So yes, function. So that's it for this lesson. So go ahead and give it a shot, and if you are needing extra help, please let me know.